Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Syed Hadi Aljunid bin Syed Hassan, and today I will be showing you how to solve step by step question number 1. So now let's head on to question 1a. The joint probability distribution of x and y is given by, as you can see in the screen. Question 1a, find the value of c and hence construct the joint probability distribution table of x and y. So first we have to find the value of c. We know that sum of all probabilities is equal to 1. From that piece of information we can form an equation which is c and then bracket the sum of all the values of x and y, 0 plus 1, 0 plus 2, 0 plus 3 and so on, and then we equal that equation to 1, and then c times after we sum up all the numbers, c times 27 is equals to 1, and then hence we know that the value of c is 1 over 27. And then the question asks us to construct a probability distribution table of x and y. So to do that, at the most left column we have is the values of x, and then at the most top row is the values of y, and from that we just have to add the numbers and times 1 over 27, because that's the value of c, as you can see in the screen. So thank you very much, and also not to forget, at the very bottom of each column, 2 over 9, 1 over 3, 4 over 9, we have to do that, and then the answer will be equal to 1, and we have to sum up all each column. Yes, and then for each row we have to sum up 2, and then we get the answers. And then after we sum up at the most right column, we sum up all the values, and then it will also equal to 1. Thank you. So question B, find the marginal distribution of x and y. So we have to find the marginal distribution of x first. To do this, we have to add across each row. So we know that when x equals to 0, the answer is 2 over 9. When x equals to 1, the answer is 1 over 3. And when x equals to 2, the answer is 4 over 9. So for the marginal distribution of y, we have to add down each column. So when we do that, when y equals to 1, the answer is 2 over 9. When y equals to 2, the answer is 1 over 3. And when y equals to 3, the answer is 4 over 9. That's all. C. Determine whether x and y are independent. So for this question, we have to know the independence rule, which is f bracket xy is equals to p bracket x equals to x times p bracket y equals to y. So we have to insert the value of x and y. Let x equals to 0 and y equals to 1, as we know this from the question. And then the value of f bracket 0, 1 is equals to 1 over 27. So now we have to find the value of p bracket x equals to 0 times p bracket y equals to 1, and the answer will be 4 over 81. So since 1 over 27 does not equal to 4 over 81, hence x and y are not independent, and that will be the final answer. Question D, find p bracket y less than 3 x equals to 2. So for this question, we have to equal that equation to p bracket y less than 3 comma x equals to 2 divided by p bracket x equals to 2. For me, I like to solve the top part of the fraction first, which is p bracket y less than 3 x equals to 2. So when y less than 3, it means that only y equals to 1 and y equals to 2 is included. So for that, I wrote it as f21 plus f22, and the answer would be 7 over 27. And then for p bracket x equals to 2, which is the bottom part of the fraction, we already know that from our previous question, and the answer would be 4 over 9. So the final answer would be 7 over 27 divided by 4 over 9 equals to 7 over 12. Thank you. Question 1e, compute variant x and variant y, hence find a bracket 4x squared plus 6y minus 2. So for this, we have to find the expected value of x, and the formula would be x times fx. As you can see, x equals to 0 and then times fx, 2 over 9. 2 over 9 we already know from our previous question, and then we have to sum up all of the x times fx, and the answer would be 11 over 9. So for ax squared, the formula would be x squared times fx. So as you can see, we have to square the value of x, 0 squared times fx, 2 over 9, we already know that, plus 1 square, and so on. And the answer of expected and the answer for ex square would be 19 over 9. And for variance, the formula of variance is ex square minus bracket ex bracket again square. So our ex square would be 19 over 9 minus 11 over 9 square. So the answer would be 50 over 81. That's our variant x value. So for and then we have to find the expected value of y. Same formula as ex. I have to just if it's ey, it's y times fy. So 1 times 2 over 9 plus 2 over 1 over 3 and so on. And then the expected value of y would be 20 over 9. So for ey squared, the formula would be y squared times fy, same as ex squared. And then final answer would be 50 over 9. For variant y, we already know that the formula is ey squared minus bracket ey bracket square, and then variant y is also the same as variant x, which is 50 over 81. So then we have to find e bracket 4x squared plus 6y minus 2. So for that equation, first we have to expand the equation, and then it will be 4x squared plus 6ey minus 2. So 4 times ex squared. Our ex squared, we know that 19 over 9, and then our ey is 20 over 9, and then minus 2. So our final answer for e bracket 4x squared plus 6y minus 2 is 178 over 9. That's all from me. Thank you.
Okay, hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Mughis Azim Basman, but people call me Muklis. So I am here to explain my calculation about the STA 206 pair assignment, and I'm going to be explaining my part, which is the second question. So the question 2A asks us to find the value of k. So we already get the joint probability density function of the random variable x and y, and since fxy is a joint probability density function, so the total probability over the entire region must be equal to 1. So therefore we get the equation is equal to 1. So we need to substitute the given joint PDF, which is we put the number. So after that, we need to first integrate with respect to y while treating s as constant. So after that, we need to multiply that by 1 over 3. So we obtain this equation. So next, we need to integrate with respect to x. So after that, we need to evaluate the integral. So after we get the equation, we need to equate to 1, since the total probability must be 1. So after we do some algebra, we need to multiply the 12, both sides by 12. So and then to simplify, after that we got the quadratic equation. So after we solve the quadratic equation, we get two numbers, which is 2 and negative 6. But because the k represent an upper limit of y and must be positive, the negative value must be rejected. Hence, k is equal to 2. I'm here to explain about the question 2b, which is find the marginal density function of x and y. So the marginal density function of a random variable is obtained by integrating the joint probability density function over the range of the other variable. So in order to find the marginal density function of x, we need to do it by integrating the joint PDF with respect to y over its range, which is y between 0 and 2. So after substitute the given joint PDF, we integrate it with respect to y. So after we do it with respect to y, we need to multiply it 1 over 3. So we already got the answer for the x. So after that, we need to find the marginal density function of y. So we do the same thing. We substitute. We put the respect to the x over its range, which is x in the between 0 and 1. So after that, we substitute the joint PDF. We integrate the respect to the x. After that, we multiply to 1 over 3 again. So after that, we will get the both marginal density function for x and y. Okay, so in this part of the video, I'm going to explain about the question 2c, which is determine whether x and y are independent. So two random variables x and y are independent if and only if their joint probability density function can be expressed as their product of their marginal density functions, which is this equation. So from part B, we already get the answer for both the marginal density functions. So in order to find the answer, we need to multiply the marginal density functions, which is the x and y. So after I multiply it, I get an answer which is they are not equal to the given joint density function. So since they are different and not equal, x and y are not independent. So that's all from C. Hi, this is the last video. So I'm gonna explain the D, which is the last question, and it is 10 marks, so this is gonna be the longest video yet. So first we are given the linear combination, which is P equals 6x minus 3y plus 4. To find the mean of P, we use the property of expectation that says the expected value of a linear combination is equal to the same linear combination of the expected values. So the expected value of P is 6 times the expected value of x minus 3 times the expected value of y plus 4. From the earlier parts of the question, we already know that the expected value of x is 13 over 18 and the expected value of y is 10 over 9. So substitute this value, we will get 6 times 13 over 18 minus 3 times 3 times 10 over 9 plus 4. And then simplifies to 13 over 3 minus 10 over 3 plus 4, which gives us the final answer of 5. Therefore, the mean of P is 5. So then next, we need to find the variance of P. I is the formula for the variance of a linear combination. The variance of x plus bx plus c is equal to squared times the variance of x plus b squared times the variance of y plus the 2ab times the covariance of x and y. So in this case, the constants are the 6 and minus 3. So the variance of P becomes 36 times the variance of x. Variance of x plus 9 times the variance of y minus 36 the covariance of x and y. From the previous calculation, the variance of x is 73 over 1620 and the variance of y is 26 over 81. Since x and y are not independent, because we do it on C, the covariance term cannot be ignored. The covariance is calculated as the expected value of x, y minus the product of the expected value of x and y. Using the joint probability density function, the expected value of x and y, xy is 43 over 54, and the product of the expected value is 65 over 81. Subtracting this gives covariance of minus 1 over 162. So after all that, substitute all the values into the variance formula and simplifying, and we will obtain the variance of P, which is 71 over 15. Therefore, the mean of P is 5 and the variance of P is 71 over 15. That's all from our group. I hope we'll get the good mark. I am sorry if my voice is not clear and I stuttered a lot. And I am also sorry for the messy handwriting.